Hello everyone, Vladimir is here with our fifth part of multi-platform game development tutorial. In our previous lesson, we've created the indicators where our hero will be standing, and we actually made a sprite display of our hero. And today, we're actually going to make our controls, and that would mean that it's the first steps to making the game, as of we'll be gathering feedback from the keyboard and our player will be moving according to our rules. So without further ado, let me get to my desktop. And you remember that thing that we did in the previous tutorial when we have been drawing our hero? Let me show you. Here it is. We actually removed the hero figure. It's not a good idea to draw the hero in our draw basis function. This is firstly. And secondly, let's just make a separate class and separate logic for our hero movements. It is important to split the display, the rendering, from the game logics itself. For example, we could make the hero movement, like changing the coordinates, in the logic section, but display it in the screen section. This is because, for example, if you need to make a pause, it will be much more easier to not update the logic part if we have moved it separately instead of if we had implemented it in our game screen class. So okay, we've removed the player drawing, but what should we do next? And we'll just get directly to logic. We'll create the logic package. Just enter the package name logic right in our core package, and after that we are going to add a game logic class, which will be actually responsible for the whole logic process. Let's just make a public constructor which will do nothing for now. Just leave it as it is, and in the same logic package let's just add the different package like objects, and in the objects package let us add the player class, which will be a class for our player. It will extend the sprite class. It is the sprite of Libgdx, which is responsible, you guessed it, for the drawing of the sprites. So it's kind of an extended image which stores some extra parameters. And for the player class, let's make some new variables. Let's make the protected integer, the private integer field x, which will indicate where the player is standing on the game field, and the same thing for y, field y. And as we create the player, we'll need to pass the initial values for those parameters and assign that to them. We will also need setters and getters, the simple ones, public int get field x, which will return our field x value, so we would not need to access it directly, and public int set field x, which will allow us to set the value of the field where the player is standing. Basically assign fx to our field, and let's do the same for the y coordinates. Public int get field y, where we return field y. Sorry, I made a typo in set field x variable. It should not return anything, so we change it to void. Now let's make the same setter for field y. Int fy field y fy. And well, the player class honestly is mostly done. I mean, we're not using it, but yeah, that's the way to go eventually. And I think in our game class, you see, we've defined the maximum base x and y coordinates for our tiles. I think this belongs to game logic, so simply move it to our game logic, by cutting and pasting, Control X, Control V, if to paste those values. Now you see that the game screen, well, it cannot resolve them, but we can help it. Just point out that those values are stored in game logic now. Let me split it into separate lines, just for the readability, I guess. And yes, the same thing in our for cycles. You see, everything should be working right now. Just to double check, launch the program and see what happened. Yeah, we see that things have not changed. And for your sanity, I suggest you to run the program as much as possible whenever you change something, especially if it's a very small program and it doesn't compile lots of time. As the project grows, it gets like more tedious to compile. The time taken is increased, but right now we can afford our luxury to compile it after every minor change and check what's going on. So, okay, we've split the logic somewhat, but we need to initialize the player in our game logic. So let's make the variable player, which will be our player. We initialize the player by creating a new instance of the class player, and we should pass the coordinates. I think it's a good idea if we randomize those coordinates, simply because, well, so the game would not be super repetitive, at least at the first launch. So we can use math_utils, a random function. It is part of Libgdx, I think. Yep, it is. Now the difference from the usual random function is that the range that we are passing here is inclusive, meaning we just pass max base x and max base y. So the values here, the generated values for field x and y for the player are going to be from 0 to 3, which is relevant. Okay, so we have this one, but, well, the game logic is not created anywhere. And even though we're storing the player inside of our game logic class, we still need to access him, well, you know, to draw it in our game. So let's just implement a getter for our player. Just function get player, which will return the link to our player. It's that easy. And the game logic for now is pretty much done. Let's go back to game screen, and whenever the game screen is created, let's just initialize the game logic, which will be our controller. Just call it logic. Logic equals new game logic. Do not pass anything there. So, okay, we have our game logic initialized, and well, the player is created in the game logic class, but you know, the coordinates that are going to be drawn on the screen are still not assigned anywhere. And same as for the picture, we have the player sprite, but we do not know, the program doesn't know what to draw there. So the first thing would be is you know, let's get our player stored, the pointer to our player stored in our game screen, just for the ease of drawing, and so we would not need to call the get player procedure from the game logic. Let's make the variable player, and player will simply be the same player that the logic has, but we are not going to change the player directly in the game screen class. The game screen class will be issuing commands to logic, and the logic will be checking them for validity. If the commands are valid, it will handle the player change, I mean the change of field coordinates and so on, the data that is related to the game and not to the graphics. But for the graphical part, we can actually set the sprite, which we will take from the resources player. Okay, it shows red. It says that the player here is not a sprite but a texture region. So we, in our resources class, oh, by the way, if you want to go quickly from one point to another, like if we want to see where this player is defined, we can just put our cursor above the player variable or class or whatever declaration you want to, and press Ctrl B when on it, and it just goes on the location of the player, which is very convenient in our case. So in our resources class, we change the texture region to sprite. Our player is going to be a sprite now, and essentially that also involves changing the constructor. So let's just create the new sprite from the region. Import the class by pressing Alt Enter, and cool, our player is now declared a sprite. And we've set the graphics, but now we need to set the position on screen. I mean, we know where he is located on the board, but we need to draw it somewhat. So let's just set position of our sprite by using our size evaluator class and getting the base screen position for the player's base. We know the field where the player is located, like this base, one of 16 bases, 4x4, so it's one of those coordinates, and according to them we can calculate the player's position on the screen. I'll just show you right now. And finally, we also need to implement the player, well, the drawing part. You see in our render function, after we draw the bases, it will be logical to draw the player above them. So we should call batch begin, which will indicate that we are planning to draw, and batch end, which will send the draw signal to the graphic card. And here we actually call player draw, and we pass the batch. This is that simple. The player already stores all the coordinates, and the sprite itself is stored inside the player variable. And you see, it is drawn here, but obviously this is not correct. It scales nicely though. Makes me feel a bit better, but no. Let me see what went wrong. Oh, this is because I've been calling the player get base x inside of get base y. Let me see what happens now. I'm compiling it, and you see it looks a bit better right now. So the player is at least located at the base. Let's repeat this process for a few times just to see that the position of the player is randomized. See? Different position, but still on the field. So far so good. So far, okay, we actually came back to the state where we were at the end of the previous lesson, but now we have to introduce something new to move forward, you know, not to let our previous successes to burden us, but to open the roads to our new achievements. That's what I think. And to do this, I think we'll need to read the controls and to act upon them, making the player's coordinates accordingly, setting the player coordinates accordingly. So our game screen should implement the control listener. In Libgdx, this is the input processor interface. If we add it, the sign goes red. This means that it kind of misses the methods. We just press Alt Enter, press Enter, and implement the methods automatically. We have some stubs which are here, and let's not touch them for now. But we need to tell the game screen, we actually need to tell the GDX engine that our game screen handles the inputs. And to do this, this is very easy. We just say that our input processor is this screen, actually. So GDX input set input processor. Okay, so we set the input processor to the screen at the constructor, but what happens when the screen is destroyed? For example, when we'll go to the main screen from this screen. And to address this, we need to also reset the input processor in our dispose method. Just set it to null, and everything will happen according to plan. Finally, we'll be setting, as I said, we'll be sending the commands to the logic. So obviously logic will need a new function. So open our game logic, Java class, and let's introduce two new functions. The one function will be checking for whether we can move there or not. We will pass the coordinates, new coordinates, and well, basically it will return false if the coordinates are bad, like if we're trying to go out of the field, to the left, to the right, or, you know, the true, if everything is fine and the player can move there. Let's return fx greater or equal to 0 and fx smaller or equal than max, and fy greater or equal to 0 and fy, sorry, the typo, and the y is lesser or equal than max base y. Of course, there could be the longer, you know, the longer check where we will just put everything in if the same condition, then we just return true, or we return else, return false. But essentially this is redundant because when we use the if operator, the condition inside already evaluates as the boolean, so we can write the small conditioning here. And the second function, which will actually assign the new coordinates, and this is going to be, let's call it public void assign player position, where we pass the new coordinates, and which will essentially just set player set field x as fx, set field y as fy. This is by no means a final stage, because when we'll need to animate everything, we will need to do more refactoring. But for now, let us just do this level of abstraction when we'll just set the commands to logic, and logic handles everything. And to get back to it, we'll just go into GameScreen function, and we are going to modify the KeyDown function. Let's just make a switch. Depending on the key code that has been passed, you know, we'll just need to move up, down, left, right. Essentially all the movement is the same. We check the new coordinates and we assign the new move. We could write a lot of spaghetti code, but let's actually implement a new function which we will call attempt move. We will be passing the changes in x or in y. For example, if we go to the right, then the dx will be 1 and dy is going to be 0. So in the attempt move function, we check if we can actually move into the new coordinates. We'll be taking the player's existing field x, we'll be adding the x value, and the same is going to be done for the y. You see, we just check if the new tile is legit at this point. And if it is legit, we assign the new position for the player, which is, you know, the same as those two values. And after that, we need to, you know, reset the sprite's position to be corresponding to the actual position. We've already did this. We're just setting the player's sprite position on screen to be equal to the player's new field x and field y position. Okay, so let's just test it by adding the key codes. For example, the key code is an integer. Whenever you press something on the keyboard, the bytecode is actually being set. Not the bytecode, but usually on all keyboards 1 byte has been sent to the computer, but now it's the character sequence, but whatever, just treat it as an integer. You get the key code that arrives from the keyboard, and then you can compare it. For example, we know the input keys, the up key code is 19. So if 19 code arrives from the keyboard, we know that we should move up. it is very conveniently saved as a constant in Libgdx, so you can easily compare it to it. So in case we press tab up, let's attempt move. The horizontal change is 0, but we're going up, so we're increasing y by 1. Let's do the same for the other movements. For down, attempt move, we do not change the horizontal, but we reduce the vertical coordinates. And the same thing for our horizontal coordinates. If we go to the left, our x reduces by 1. So reduce it by 1, and y stands the same. We're not moving vertically. And the opposite thing in case we move right. Our x is going to be increased by 1, but y, we're not touching the y. Let's see how it works. Let's see if it's working. You know, this magical moment where you run the code and check if it's working. And you know what? Even if it's not working, never be discouraged. I think, well, it's impossible to get a lot of things on the first try. And the programming is one of those. I'm actually surprised if something is compiled and works the way I intended to. See, I can move up and down right now, but I cannot go left and right. And it's up to me to figure what is going on. That's what I was talking about. But you can see that I can move like in vertical and horizontal, in vertical directions. So in case I had the left key pressed, I was using it. In this situation, you just need to, you know, debug things. What do I have in this? Can move function seems to be working properly. So to debug it, I'm just going to, I can either run a debugger and put the breakpoints, which is actually a better solution. But since I'm showing a video, I'm just going to... No, actually, you know, just to show you what's going on, I put a breakpoint here, then I run, instead of pressing the run key, I'm pressing the key to the right, which means debug. And after I press the key, left for example, okay, we see that my breakpoint has been hit. This thing is called breakpoint. I know that the x value is -1 and the y value is like 0. My screen looks the same, so I should theoretically be able to move to the left. So what's happening? Let me go inside the function of assign player position and go to implementation. I'm calling the run continue resume program F9, and it hits the next breakpoint. So yeah, it correctly tries to assign the fx value to 0 so that the player would be standing to the left. Let's go to the set field. Okay, and you see, I already see what the problem is. You see, I've used the same functions, set field y and set field x, just because they look so alike. So yeah, I see what's going on. I can stop debugging for now. I'm stopping. I just press stop everything. And right now I will be able to run it and it will hopefully work properly. Yeah, that's what I was talking about. You can't always expect things to work, but you need to do your best to make them in the best possible way so they are working. I think this is your duty as the game developer and as a programmer, as an artist. Never ever print out, deliver half-baked products. And you see, okay, the man is walking properly now. It feels very good. I think this could be the end of our tutorial, but one thing to break the party, you know, if I resize the screen, you see what's going on. The player is actually, it doesn't look good. So we will need to update the player's coordinates, which will essentially be the same thing for size evaluator. Because our stage width and height changes, the size evaluator will be giving the right coordinates, but we were not updating them in our set position function. We only called it after we moved. So right now, actually let me demonstrate it real fast. If you see, we have our character here. We resize it. The screen changes. Our character is in a terrible place, literally. And after that, we press the key, and you see everything is working fine. He is in the right positions. That's because the size evaluator already gives us the correct values, but it does not refresh after we resize the screen. So you know what? Let's just make the function refresh, which will refresh, you know, the elements after resize. We'll call it refresh. Let's just go for refresh player for now, just in case we'll need to do something later. And put the call after in attempt move. Put the call in our constructor, where we call the set position function. Yeah, call it everywhere. And call it after the resize. Our viewport got updated, and we should also update the player. And let's see what happens now. Let's resize it. And you see the player keeps position right now. And I find it very good. I think this concludes our tutorial. And tomorrow, in the next tutorial, we're going to discuss how can we actually implement the enemies. How can we make them, you know, strike the player so he would be able to dodge the attacks. And we'll see how far we will get. Thank you for watching. Check the comments below, and I'll give the links to the code and to the group where you can question things and ask me the questions if you need something. Thank you for watching again, and Vladimir is out. See you next time. Cheers!